Today we'll see about how pointers are being declared initialized in CPP, as well as how they are used in arrays and structures, and how you're pointing it using to objects. Pointer is a variable that holds the memory address of another variable, and both the variable as well as the pointer must be of the same data type. Each variable would be having some memory address, and that memory address is being stored in a variable called as a pointer. This is mainly useful in times of dynamic memory allocation, when you want the function to return more than one value, then like those applications. How you can declare and initialize pointers. The general syntax is data type star variable name. Example given here is int star x, float star x, character star z. So x is a pointer of type integer, y is a pointer of type float. So they can hold the address of any other variable. That is, x can store the address of variable which is of type integer. So star is called as the indirection operator. You're having the address operator ampersand, which gives you the memory address of that particular operand. For assigning, you are using int star ptr equal to ampersand x. The address of x would be stored into the pointer ptr. In the figure, you can see the address of x is being assigned to ptr. The same example, you're printing the value ptr, it will be giving the address. You can see in the output, the address would be printed. In the second printf cout statement, you're having star ptr. Star here is used as the indirection operator. It gives you the value at that particular address. ptr is having the address of x. So value at that address means it will be printing the value of x. So you can see in the output 10 is being printed. Next is pointer arithmetic. You can have addition operation as well as subtraction over pointers. Multiplication and division are not allowed. The difference is when we are adding 1 to the pointer, depending upon the data type, it is incremented. Suppose your pointer is of type integer, the address of the pointer will be incremented by 2. If your pointer is of type float, it will be incremented by a factor of 4. That is called as a scale factor. So if the current address of x is 1000, then x plus plus, it will increase it to 1002 and not 1001. Similarly, when you're doing subtraction, it will be decremented by a factor of 2 if it is integer. If it is float, by a factor of 4. If it is character, by 1, because only one byte is present for character. Next is when you're declaring arrays. Actually, when you're declaring int x of 10, x is a constant point. It is called as the base address of that particular array. So x of 0 will be having the base address of that particular array, and we cannot change that address of x. So that's why it is called as a constant pointer. It will be pointing to the first memory allocation, that is x of 0. Now how you can make a pointer point to the arrays. So you have declared an array int x of 5. 5 memory allocations will be allocated. Int star ptr equal to x. So x is actually the base address of that particular array. So simply you can assign it as ptr equal to x, or you can write it as ampersand x of 0. That is the address of x of 0, the first element. So both the cases are same. Now you can increment the value of ptr plus plus, but you cannot increment the base address of that particular array, that is x plus plus is invalid, because I told you x is a constant pointer which cannot be changed. But for assigning or displaying, you can write it as x plus I can be accessed. So when you're writing x plus I, actually the value of x is not changed, only it is added along with it. But when you're doing x plus plus, the actual value of x is being changed. So there you will get an invalid statement. but the x plus I statement is correct. Now how you can print the arrays in different forms? It is given as 3 columns. See the first case, I equal to 0, I less than 10, I plus plus, Cout star ptr plus I. Ptr is having the base address. Ptr plus I, it will be pointing to the I plus 1th location, the value at that particular position. Or what you can do is, the next column, Cout star ptr plus plus. First it will get the value of star ptr and then ptr would be incremented. In the third case, value at x plus I. X plus I and ptr plus I, both are the same statements. X is not changed. You are adding a factor I with x and then you are printing that value. So all three statements will give you the same output. Now how you can assign pointers with character arrays or strings? You're having character array str which holds the value computer. str0 is C, str1 is O, str2 is M. Similarly, it will be allocated a size of 9 bytes. And character star CP is a character pointer. It is assigned the value of str. So the base address, that is the address of C, would be assigned to the pointer. Cout str would be giving you computer. Same way Cout CP would be giving you the statement computer. See the next statement, Cout str of 2, array index 0, 1, 2. It will be printing the value M. Similarly, CP of 2, it will be printing M. CP plus 2, that also would be printing M. CP is the base address plus 2. So here also what you're getting is the same way as how you have assigned to arrays. Next you're having is array of pointers. Like the other variables, you had integer array, character array, floating array, structure arrays. Same way you can have array of pointers. Mostly it is used for storing two-dimensional arrays. Suppose you are having a string array, so you require an array of strings. So first it will be accessing the row, the second part is a column. So you have a pointer vehicle of arrays. Vehicle of 0 will be giving you car, vehicle of 1 will be giving you van. So vehicle of I you are printing, and I refers to the index value. What is a constant pointer and what is a pointer to a constant? Constant pointer means you cannot change, once you have assigned a address to that pointer, you cannot change the value of that particular pointer. That is, the address cannot be changed. Now pointer to a constant means it will be pointing to a constant and that constant value cannot be changed. The pointer can be changed to any other location, but once it is pointing to a constant, the constant value cannot be changed. We will see some examples. In the first case, we are having the normal case, normal variable and a normal pointer, that is, it is not a constant. So x equal to 10, y equal to 20, p1 is pointing to the address of x, and you're changing the value at that particular address as 20. So x can be changed. Also you can make the pointer p1 to point to y. No issue in all these cases because the variable as well as the pointer is both non-constant pointer. See the second case, you are having x and y as constant int x equal to 20. This means that you cannot change the value of x or y either directly or indirectly. Indirectly means you cannot change it using a pointer. Now see, pointer P2, it is pointing to the address X. Using P2, you try to change it, the value of X to 50. That is invalid because it cannot be changed. Now P2 equal to address of X. That is possible because you can assign the pointer to another variable. No issue in that. Similarly, if you are trying to change the value of Y using P2, that becomes invalid because X and Y both are constants. See case 3, you're having X and Y usual variables and P3 is a pointer that is constant. If you're having a constant pointer, once you assign the P3 to point to X, you cannot change the address inside P3. That is, if you try to assign P3 to Y, it will show invalid statement. But using P3, you can change the value of X because X is not a constant value. In case 4, both the variable as well as the pointer is constant. So you cannot change the value of P4 once it is assigned to X, as well as using P4 you cannot change the value of X because X is also constant. Next is, what is a reference variable? Reference variable is a name that you're giving to another variable. It is just like an alternative name, like you're having a pet name. Pet name means your formal name as well as the informal name. Both are pointing to the same person. Similarly here, you are having sum and num. Both are pointing to the same memory location. Both will be having the same value. So if you're changing either the sum or num, both will be affecting the other variable. See in this example, int num equal to 10. Num is a usual variable. Int ampersand sum, which is pointing to assign to num. So sum is a reference variable which is referring the same memory location as that of num. Any change in sum will be reflected in num. Any change in num will be reflected back in sum. You can access sum as how you are accessing num, not like pointers. For pointers, you will be using the indirection operator. Here, indirection operator is not required. You can simply write it as sum. Now, reference variable is used when you want to return more than one value from the function, like your or you can return back large objects, arrays. All these are being done using reference variables. Now we'll see a small example how you're passing the argument as a reference variable. Function cube, it is taking an argument as a reference int ampersand x, and you're changing the value of x as cube of x. In the main function y equal to 10, you have printed the value of y as 10 and you are passing y as reference. So now x is pointing to y, the same memory location. So any change in x will be reflected back in y. You can see from the figure there is no separate memory location for x. It is simply x and y is both pointing to the same memory location. So any change in x will be reflected back in y. Now when you're printing the value of y, what you're getting? You will get the cube of 10, that is 1000. Now we'll see how you are passing functions using pointers. When you're passing function arguments as pointers through functions, the address will be assigned to an pointer. Okay, and the one that you're passing is called as the actual argument, and the one that you're declaring in the function is called as the formal argument. Any change in the formal arguments using pointers will be reflected back in the actual arguments. We can explain pass by pointers using a small program of swapping two variables. The swap is a function m and n are pointers. Temp is a temporary variable. temp equal to star m. So value of m is assigned to temp. Star m equal to star n, value at m equal to value at n. Value at n equal to temp. Coming in main program, a equal to 5, b equal to 6. The value of a and b equal to 5 and 6 respectively. Now you're calling the function swap, you're passing the address of a and you're passing the address of b. So address of a will be stored in m, address of b will be stored in n. Now you're calling the function temp equal to star m. Value at m means value at a. So a is 5. So temp becomes 5. Value at m equal to value at n. What is n? Address of b. Value at n is 6. Value at m is actually the memory location a. So b's value 6 is assigned to a. Value at n, that is b equal to temp. Temp was 5. So b becomes 5. Now you got a and b as 6 and 5 respectively. So using pointers, if you swap, you get the values swapped. If you simply pass the values of a and b to usual another variables b, c and d and swap c and d, it will not be reflected in the main program because call by value, any change in the formal arguments will not be reflected back in the actual arguments. Here we are comparing pass by value, pass by reference and pass by pointers. In the first case, pass by value, actual arguments and formal arguments have separate memory locations. So any change done in the formal arguments is not reflected back in the actual arguments. And the method in which you're passing is int x. That is a simple variable. X is a normal variable. In pass by reference, formal arguments and actual arguments both share the same memory space. Both are pointing to the same memory space. So any change done in the formal arguments is reflected back in the actual arguments. And the way you're passing is int ampersand x. So ampersand x is the reference variable. In pass by pointer, you're passing it as address. So formal arguments will be pointing to the address of the actual arguments. Any change in the formal arguments will be reflected back in the actual arguments. So int star x is the pointer that points. This is an example for pass by value. You're passing from the main function cube of y and you're accepting it in the function cube as int x. So y will be copied to x. So x is changed to x into x into x, but no change is happened to the variable y. When you are giving the output y equal to 10, after calling the function also y equal to 10. See the second case, pass by reference. You're passing the value as cube y. You're accepting it as cube int ampersand x. So y is being referenced to by x. So any change in x will be reflected back in y. So input y's value, initial value was 10. After calling the function, it became 1000. In pass by pointer, you have called cube by passing the address of y and accepted it as int star x. X is a pointer that points to the address of y. So any change in x will be reflected back in y. So the output is 10 and 1000. This is the diagrammatic representation of the program that we have discussed just now. In pass by value, x and y both are having the different separate memory locations. X is the formal argument, y is the actual argument. Formal argument has been changed, x into x into x, and got as 1000, but it has not been reflected back in y. See the second case, pass by reference, both x and y are referring to the same memory location of y. There is no separate memory location for x. So any change will be reflected back to y. Third case passed by pointer, X is having a separate memory location, but it is referring to the address of Y. So any change using the address will be reflected back in Y. So in the first case, no change in Y. Second and third case, both changes the value of Y to 1000 X cube. Next we will see how to make pointers point to structures. The general syntax is structure name, or you can call it as the structure tag, star structure pointer variable. Now see the example over here. We have declared a structure, struct student, which is having roll number and name. S1 is a structure variable of type student. SPTR is a pointer variable of type student. And we can make SPTR point to S1. In the main program, we have read the name and roll number. S1 is the student structure. So you're reading it as S1.name and S1.roll number. In the next statement, we have made SPTR to point to S1. So SPTR equal to address of S1. Now using SPTR, how will you access the name and roll number? We can access the name and roll number using the arrow operator. It is also called as the member access operator. SPTR arrow roll number equal to 20. So whatever we have entered would be changed to 20. And now when you're printing SPTR of roll number, SPTR of name, you will get the name and roll number as the output. So when accessing the structure details using the normal structure variable, you are using the dot operator. When you're using pointers, you are using the arrow operator. All the other operations are the same. Now how you can create pointers to objects? It is almost same as that of structures. Instead of structure tag name, you are having class name star pointer to object variable. Any pointer name you can give. So you're having in this class student, you're having name and roll number, and functions to read data, that is in data, and to display data you're having show data. You're closing the class. All these are the same as how you usually create the class. Define the class, members, and the member function. Now in the main program, we have declared object S1 of class student, and you have declared SPTR, a pointer that points to the object student. So using S1, how do you access S1 dot in data? In the next line, you have used assigned SPTR equal to address of the object S1. Using S1, you can display data as S1 dot show data, and using pointer, you can use it as SPTR arrow operator show data. The same thing as structures. You will be using the arrow operator for both structure as well as objects.